Hi there! In this video we continue our practice. Previously we applied tests for data quality, data stability and data drift for the raw data and for the data after feature engineering, and now we're going to proceed with the model, right? Previously we trained the model and we're going to use this model in order to generate some predictions, and our idea would be to apply the model to generate some predictions and see what we can measure with help of test suites on top of just model's output when you do not have labeled data, and after, when you received labeled data, we are going to access the model's quality, right? So that's our plan. Let us start from the importing some libraries we're going to use and then loading the data. It will be pretty similar to what we did before, so I'm just going to implement it quite quickly. Now let's import libraries. Previously we used the following evidently test presets. We used data quality, data stability and data drift test presets, and now we're going to use node target performance preset. This is a very well designed preset which suits you when you already have model's output but you do not have labeled data yet. So let us import this preset. Binary classification test as well, because eventually we will get our labels. And maybe I will import data drift test preset just in case you want to use that. Oh, here we are. Now let's load data and we're gonna do a small trick here. I'm going to explain it in a minute. Here we loaded our bank marketing data, and instead of splitting this data into training, reference and the production simulation part and then applying the feature engineering to those parts separately, which is somewhat very similar to what you would have in your production pipelines, I'm going to implement a small trick here. I will first apply feature engineering process to my whole dataset and then split it into parts. The reason I do it is that our feature engineering function is implemented in a way that doesn't really take into account the fact that later in production we might get some more categories, and when we do one-hot encoding we will get some new categorical features, and vice versa. We could lose some features if we do not see any features which we had during the training phase. Vice versa, what we could do is we could try to apply this feature engineering process to the production data and then just refine the structure of our dataset. I mean, remove new columns which we did not have during the training data and add the columns with the missing values if we miss some columns, if this category is disappeared from the data. But I decided to take the fastest way so that I can demonstrate how this test suite looks like, but for let me remind you, for your production usage, to implement your feature engineering process pretty robust, because that's literally what could happen with your features if something has changed in your categories, right? And if you do not account for it, then the structure of your data set from training to reference or from reference to a new batch of data can change, right? And if your model is not robust to such changes, and in most cases it is not, right, we will get some errors. So that's why actually we need this all test suites to test the data structure, to test whether our reference and the current data are the same or something else. So that's actually pretty huge for production pipelines. So now I kind of expect some issues with the data, because I know that I process categorical data with help of one-hot encoding, and that's not very robust procedure. So in order to get some hack here, I just will apply my feature engineering to the whole dataset, then split it into parts so that I'm sure that the structure is the same, and then apply my test suites. Then I split my data into parts. I even feel like I'm doing something wrong, so be careful with that, really. Now we have slightly another data frame, right? And we can even check the size of our data. For instance, let me check the shape for my training data, pre-processed one, and you can see that now I have like 49 columns here. If I'm not mistaken, previously we had something like 37, which means that in a couple of categorical features now we have like additional category, right? Well, how to deal with that? I suggest us train the new model and then work with that model. Actually, I already have one, so I'm going to load the model. And maybe I should leave for you a code how to train it. Or not, what do you think? Okay, let me just do it in case someone wants just to have the code work in run all mode. So that's the model which suits us, and let me just write for you code to dump it. I actually can even like load this model. So now we will have like entirely same code, and I'm going to comment that because we only run it once. And now let's load our model. So I will use very similar structure here, but now I will open the file for reading. The reason I even have this step is because generally when we work with production pipelines, we do not train the model right there, right? We rather load it from the source where we have like our trained production models. So this is why I just wanted to show the step, like you load the model from the source and now you're going to apply this model. So yeah, let's proceed. I'm going to apply this model to the reference and production simulation part of our data. Let me do that. I will just create prediction columns here. This is somewhat similar to what you would do in your production pipeline. So you either access your model via API or just load the object right from somewhere, and then you predict on top of the features. I'm gonna use method predict, right? Then pass my data. And again, as we have only toy data set, our target is right here, so we should not forget to like exclude it from our data. And very similar instructions to our production simulation data. Now should be fine, let's try. Now we have the right data frames, and now we can try to implement some checks on top of models output and both models output and the target. Let's do that. As I mentioned before, in Evidently we have very nice test preset which is called No Target Performance preset. This is a preset which is designed exactly for cases where you already have your model and you generated the output of your model, but you do not have target data yet, so that you cannot directly measure model's quality, but you already can measure quite a lot of things on top of model's output. Let's see how it looks like. I will create this No Target Performance suite, and again I'm gonna build test suite from Evidently, but now I pass No Target Performance preset as a test. Here we are, and now I need to run the calculations. I do it with help of method run. I need to pass here my reference and current data, which gonna be processed data reference and processed data production simulation. And for production simulation, I can go for the first batch or just for experiment for the second batch. Let us try both. I would start from the first. Right, so that's how we calculate everything. And finally, let me show it right there inside of Jupyter Notebook. What is wrong is our functions, batch size, okay, it's a current data, of course. Now should be better. Yeah, so we have that there are quite a lot of tests. We have more than 100, right? And a lot of test success, 101. Only 7 tests failed, and let me quickly show you what do we have in this No Target Performance preset, because I believe it's very interesting. So we start from drift for prediction. It's drift for model output, and this is very important and very good metric for the case where you only have model's output. Imagine you have no drift for model prediction, right? And you have no drift for input features, at least for important ones. In this case, you can consider with like high level of confidence that probably everything is good enough with your model because there are no changes in the features and no changes in model output. And even if you do not have target data, you can more or less believe that everything is okay. So in our case, we can see that the prediction feature is not drifting, and share of drifted columns is comparably small, only 6 out of 50. So probably that's our case. Probably that's quite okay. And together with drift metrics, we also have quite a lot of important things relevant to No Target Performance, right? Which is like data quality, column types, share of missing values in different columns, etc., etc. So it really helps us to assess data quality as a proxy to model performance in case we do not have labels and cannot really evaluate model's quality. But we have quite a lot of proxy metrics which are well combined and helps us to catch any issues with the models itself. Right, so that's how it looks like. And what else interesting to show? Let us try to apply the same test suite for the next batch of data, because eventually that's exactly what we are going to do in our production case. So now instead of first batch of data, we're going to use the second batch of data. So luckily I already have batch size variable, so I can just go for the next batch. Let's say our call center worked for the next day and then we received the next batch of data. So I just updated the slice from processed data production simulation. So let me show this. First it calculates, and now I can see that we have 8 failed tests, right? So we can see that quality is slightly decreasing, and probably there are some changes in our data. And even without like proceeding to the details of our tests, you can continue to see what's going on here. I think that might be very interesting, so I'm just going to show you how you can play around with that in your Jupyter Notebook, knowing that it's not like a real pipeline, but still very interesting, I believe. So that's how you can play around with historical data. So let's calculate, and you can see that the amount of successful tests decreases and decreases and decreases, which makes total sense, right? In case you have some strong seasonality or maybe other reasons why our data changes during the production, right? So that's very interesting, I would say. But let us remember our main goal, and our main goal was to explore how we can implement checks for our prediction pipeline. And previously, in the previous video, we discussed how we can implement data stability, data quality, and data drift checks. Now we saw how we can implement no target performance check just using test preset from Evidently. And now finally let's evaluate models quality. For doing that, I'm going to create new topic. Now, instead of no target performance preset, we're going to use binary classification preset. So let me just, that's binary classification test preset. And in order to avoid any mistakes, I will recreate the test suite object. So I just will use, let it be model performance suite. I think very nice name. So let me move back to my first batch. A little bit interesting, but with having such syntax, it will be much easier for me to iterate on different batches. That's pretty small one, right? We have only 5 tests, so that's drift for target, and we can see that there are no target drift, so target is more or less the same, right? And we have also accuracy score, which is quite similar to what we had in the reference data. And when it comes to precision, recall, and F1 score, we have failed tests. Let us go inside and see what's going on here. Let us explore the details here, and we have a confusion matrix calculated for current and reference datasets for all this precision, recall, and F1 score metrics. And you can see that, during the reference, we had like 52 errors plus 4, right, for misclassification. And when it comes to the current, the amount of the number of errors for misclassification is increased. And the reason why I can that easily manipulate with such statistics is that my reference and current have equal sizes. If it's not like this, you would need to normalize the errors. But here we can see that definitely the amount of errors increased, right? And this influences both precision, recall, and F-score, of course. So probably we would need to intervene and do something. That's might be one outcome. And the second outcome will be, probably we need to do something else, like maybe just automatically generated thresholds for tests are not suit us anymore, right? Because let us take a look at the recall. We can say that our recall now is equal to 0.07, but previously it was much worse, right? And we have this alert, so something is wrong, but maybe it's for better, right? Maybe not. So this is why sometimes it's better to invest some time, especially if you have not that many tests, right? Like here, only 5, and introduce to the test suite your own conditions. In the next video, we are going to define the customized test suite, and we will be using some customized test conditions so that we can say to test suite exactly when to alert us. Let's dive in.